Alright, hey guys, welcome back to another video, and this one's going to be dedicated to learning about similar triangles. So similar triangles, you'll probably see 1 to 2 questions on the SAT or ACT, and it's usually in sort of the geometry problems that you'll get into since it deals with triangles. Alright, so let's get started. First, what we're going to talk about in this video is really the definition of what a similar triangle is, just so that you have a basic idea of what I'll be talking about in this video, right? So it's triangles, it's 2 triangles that have the same angle measures, so all 3 angle measures are congruent, and side lengths that are proportional to each other. And I'll start to get into what kind of proportional means when I set up a proportion to solve a practice problem that we're doing. But it's basically that the sides of each triangle kind of follow the same ratio so that you can use a proportion to solve for them, right? Alright, so let's get into our first example here, and what I've done is written out 2 triangles. So first you have triangle ABC, and that's the bigger triangle that you're looking for, and then you have a smaller triangle, it's A, B, C, So you can clearly see that there are 2 triangles in this picture, and I'll start to go over why we know they're similar triangles after this. But you just know that you'll start off with a bigger triangle and a smaller triangle, and they'll fit these conditions above, and I'll tell you how to find if they have the same conditions, right? So first, to find that, you're going to look at the first part of the definition I gave you. It's that they have 3 congruent angle measures, right? So we can tell if they have congruent angle measures if you look. Okay, so first I have A, and you see in the A angle you have 1 line around it, and you see that there's a corresponding line in A comma's angle measure, right? So if they have the same number of lines in the corner, that's kind of the mark to tell that these 2 angle measures are congruent. So whenever you see that on the SAT or ACT, which will do, you see, okay, this has a line in it and this has a single line in it as well. That means that those angle measures are congruent, right? So we know that all the A's are congruent. And then we go up to B. We know that B is congruent just because both triangles hold B in both of the triangles, and that means that B is congruent with B, right? And then you go over here, so C and C comma, it's the same thing as A comma, right? So you have 2 lines in this angle and 2 lines in this angle. That means that they are congruent as well. So we fit the first criteria of having all 3 angle measures be congruent and the same, right? So then let's look at kind of the side lengths being proportional, right? So I think it's easier to show this part if we actually dive into the practice problem that I have here, right? So the practice problem is, what is the length of BC, so it's B all the way to C, this line segment, when AB, so here to here, equals 15. So this entire side of this AB is 15. Then you have A comma B equals 5, and BC comma, which is here to here, equals 7. Alright, so you're trying to find out what BC is, this long part of the big triangle is with these kind of parameters that they give you, right? So what I mean by being proportional is that you can set up a proportion to find that longest side. Alright, so that's what I'm going to do right now. So I'm going to start off with the side lengths that I think correspond to each other, right? So I know that you have 1 big triangle and 1 small triangle. But if they're similar triangles, you know that each side length kind of has a partner. And I like to think of it as this A side right here, that is kind of the partner of this side right there, because those side lengths will be proportional to each other. Right. So I'm going to set it up like that. So I'm going to take this, of the smaller triangle, I'm going to take A comma B, and that's going to be 5, right? And I'm going to put it over the partner side. And the partner side, in my case, would be AB, right? So I'm going to make that over 15, right? So right now you have 5 over 15. And I do this just because, and you may be wondering why I know that those are partners. I know that this AB is basically the extension of A comma B, right? So it's on the same side of the triangle, and all it is just it's a little bit longer, which means it's proportional to it in the bigger triangle. All right, so I have that side. So let's start looking over here. We know if we're following the same pattern over here, we have BC comma, and that's 7, right? So we're going to put the smaller ones on top, like we did before. But then we're trying to find BC, right? And BC is also the buddy of BC comma, right? As we followed before, just because it follows the same line, has the same angle measure, that's very important. And you're drawing this line and it's a little farther, which means it's proportional to BC comma, right? So you know that this bigger side has to go in this blank here, and that's what we're trying to solve for. So all you do is write X there, and that X is kind of a placeholder just so you can solve for it afterwards, right? So then we're going to cross multiply. So I'm going to do 15 times 7, which is 105. And set that equal to 5 times X. Right? And then you're going to just solve for X, and in this case, you just divide both sides by 5. So it's 105 divided by 5, and that equals 24. So that equals X. And in this case, X equals BC, just because BC was actually the buddy of BC comma, right? So I just drew that as an X just because I wanted to use a simple variable, but you could also, just so you remember it better, you could also write this as BC. That's what you're trying to find, the length of BC, right? So this is how you find it. Let's do a quick recap of what we learned in this. So similar triangles they have the same angles in the two triangles, and the only thing that's different is their side lengths, right? And you know that they're similar triangles because those side lengths, even though they're different, they're proportional to each other, right? And that happens because all of these side lengths are congruent to each other, right? So you know that you can either multiply or divide on the sides to get another triangle, and that's basically what you get here, right? So in order to solve problems like this, you would just set up a proportion. You would use the two side lengths from one of the two triangles, whichever one they give you. In this case, they give you 2 side lengths of the smaller triangle, right? And you can always use that to find out what the angle or the side lengths of the bigger triangle are. So in this case, we had 2 side lengths of the smaller triangles. I like to put those in the numerators just because they're smaller. That's what you can do. 5 and then 7 on the top, and then set them equal. Right, and you know your denominators are going to be the bigger sides, their partner, bigger sides. So in this case, we knew that AB was the partner of A comma B just because they're on the same side, and share the same angle right over here. All right, and that's how we know that their 15 was the partner of 5, so you can just put 15 under that 5. And then you're solving for BC, so cross multiply, and then solve for whatever BC is, right? So that's how you do it. Let me know if you guys have any questions, and thanks for watching. I hope this helped.